Okay, so at the top you can see it says recording for the ones that record. So whenever that shows up when someone's Zooming with you, it's recording. So with this one, if you go up into that first little chunk of information, it says the water is flowing into a small tub at a rate. The word rate there tells you, hey, this is the derivative. And so it's a tiny word that doesn't seem like it's a big deal. And so that means f of t is going to be a derivative for us. And so in part A, it wants us to write an equation for the locally linear approximation when t equals 3 and approximate the volume of the water at that time. And so with it, local approximation means tangent line. Does that make sense?
Yes. Can you say that one more time because my video stopped videoing for a second?
Yeah. So when it says local linear approximation in part A, that means, hey, we're going to take the derivative here.
Okay.
Not derivative, I'm sorry. I was referring back to the earlier part. It's saying we're going to use our tangent line. So right now what you need in order to calculate the rate is, let me see if it'll let me do whiteboard. I saw that that was an option somewhere.
I think it's under share screen, like hit the button.
Okay.
It'll come with whiteboard or something.
We will find out. Okay.
Hey.
So this might get really messy because I have a touch screen and my handwriting has been absolutely horrible on my computer lately. So it's going to be worse than usual. So for a tangent line, it would be, yep, that's not working. Y equals my slope, and we're using t in this one. And so what am I approximating?
The
linear
volume
approximation of W at time t equals 3. Okay. So instead of, I'm going to clear those. So I need the slope and I need a point. Well, they gave me the point in part A because they told me my point was t equals 3 when the volume was 2.5. So you'll use that when you write your slope equation, your linear equation. And so I'm approximating W. So what I need is I need W of t. We need to figure out what that is because the slope is W prime of t. Does that make sense? Okay. Do I need a pause or am I good to keep going? Okay. So going back up into that first chunk, it tells me the volume is given by W of t. And so do I have any water in the tank at the beginning? Did they tell me that information?
They say that there's 2.5 cubic feet of the tub or volume in the tub. So I don't know if that means water in the tub or not in the tub.
Where does it say that 0.5?
Are you talking about part D, Daniel?
You muted yourself, Daniel.
I'll try and find it.
Say that again. You're muted. I unmuted you.
Oh, sorry. In part A, it says there's 2.5 cubic feet of water in the tub.
And so that's not going to be at the given time? Oh, never mind. We don't need to know how much is in the beginning.
As at time t equals 3, there's
Yeah. And so I care about the derivative at 3. That's what I want to find out. And so the derivative of the volume is going to be the rate at which the water is flowing in and flowing out. So in would be positive and then out would be negative. So the positive amount that's flowing in, is that F of t? And then, sorry, this is really bad, guys. And then the amount flowing out is L of t. That's being leaked out. So my W prime of t, see if this will be better. This is a hot mess. I need a stylist. Okay. And so now I can find the slope I need needs to match this time here. And so I need to find W prime of 3. And what will make this easier for you is to go in and type in 3 in both of those functions. There's not going to be a shortcut. So in your calculator, since this is a calculator question, this would be your arctangent of, I'm going to disappear for a second. I don't even know if I can see my camera. Oh, not full screen. The pi over 2 minus 3 over 10. And then my L of t, which I will subtract from that, is plugging 3 in for that t in there. So the 0.03 minus t squared minus 75.
I have a question. It says on the thing it's for or L works from 5 to 10 if t is between 5 and 10. So does that affect it at all?
It does. I missed that detail.
Yeah, I thought it was L doesn't exist at this time value.
So would it
Right.
just
So we don't have to deal with that part.
so it'd just be f of t?
Yes. And so in part B, when it's asking for the second derivative, you would have to take that time into consideration for L of t, because it will be in place since it's after the 5 seconds. And with this one, because this problem was mentioned that it was a calculator problem at the beginning, for part B, use your calculator and make that problem 10 times easier. Okay. Questions?
So for part A, do we do W prime of 3.5? Is that still F of 3.5? Because the second part of the question asks for us to like.
Yes, and so you're gonna have to write your line out. So I'm gonna write it as my volume, or you can say my W of, let's undo that, of T is approximately that line you found. Hi, Michelle. And so since it's approximately that line, it's going to, you'll plug in 3.5 in here once you have your line. And that'll allow you to approximate that value. And I know that's only like halfway right now. Well, but I'm trying to give just enough for you to form some of your thoughts together.
So how did we go from
What was the rest of that question, Daniel?
how did we go from W prime to W?
Okay, so the question said, I want you to approximate. So W, notice I have, let me change the color so it'll stick out a little bit more. Notice this approximate symbol down here. So that's not saying I have W, it's saying I'm approximating W with this line that I wrote. So that's that first part of part A. It asks for the approximation. It asks for the line that could approximate anything. And then I can plug in any number around 3 to where I could plug in 3.1. It doesn't make sense to plug in 10 because 10 is too far away from 3. But linear approximation was when we learned that my tangent line can approximate things really close in size-wise to the number at hand. And so all of this stuff above that line was the stuff that I needed to find in order to write my line out. So you'd still have to go and write it in point slope form and convert it over into slope intercept in order to use it.
So it has to be in point slope form. We can't already put it in slope intercept.
You can use slope intercept if that's really your preference to start with. And so you have to have it in slope intercept no matter what in this case, because I wanted the linear approximation line. It's not just a tangent line. So this is one of those cases where it's easier for you to go ahead and change it over because the application you're using it for in the next couple steps. Other questions?
Okay, I know I just got here,
No,
but
Michelle.
so the line that you're talking about is using the derivative of W and then like plugging that in with the point.
Okay, so a linear approximation is a line using information, it's using a tangent line. So a tangent line, if I was using, because I'm using W and T this time, it would be W of T is approximately equal. Why is that not going away? Sorry. I know I'm just having red dots appear. Stuff isn't disappearing on my screen for me to actually like use it well. Okay. So then I would have the derivative of W at the value I'm approximating around times T, because I'm writing a line, so I need a slope, I need my X, and then plus my Y-intercept. And so to find all of that, I use the given information that they provided me with. that should actually, I guess, be a W.
Okay.
So I'm just writing a tangent line out. It just happens to be not in terms of X and Y, which is probably the part that feels more frustrating in this problem. And so everything below here was me finding, or at least talking about, the slope and the point in order to find out where everything went. And Michelle and Daniel, I don't know if you knew this, I am recording this one so I could post it later for those who needed help who are missing this.
Okay.
If you don't want your face seen, you're welcome to turn off your videos.
You have my consent to record.
Thank you, Daniel.
Also, I may disappear temporarily, but I can still hear it because I am currently in the middle of baking my mom's birthday cake.
I did notice the apron.
Okay, so then how does W prime equal F of t minus L of t?
Okay, so up in that top of that first little chunk before it says part A, some information. And it told me that F is the rate in which water is flowing in, and rate means derivative. And then a little farther down, it told me that L of t is the rate that water's flowing out. And so remember, this derivative of volume would just be how much is coming in and out at the same time. So that's a little bit of our like related rate information. And so the reason we marked out L of t is because that's not valid for time t equals 3. And so that's why we don't need L of t for this particular part. But if I was talking about like t equals 7, that's when L of t does apply. And so I would have needed to keep that part. And so I know for part B, it's asking about W, the second derivative, which you would need your first derivative to take your second. And so in that case, you would need that L of t in part B.
Okay. I think I almost got this then. Maybe.
Okay. This is stuff that we covered back in like, I would say like October, November, December. So this is like reaching pretty far back in terms of an application. So it's not like we did this yesterday. I knew that there was going to be a little bit of maneuvering around these first few sets as we're getting used to these derivative applications again.
Honestly, when they said we're going online, I kind of forgot everything that we did within the past year. So,
Yep, we're going to pull that out as we work on your portfolio. Okay, do we feel a little bit better about number 1? Okay, I'm at least getting 1 or 2 nods. I have too many of you. I can't see you all at once anymore. Okay, so do we need to talk about number 2 or a different part of 1?
Is there 2 questions?
No, this one's only 1 set. That's just 1 question for today. I lied.
Okay, I was like, I don't have that. I don't know what's going on.
No, that's because I was going to sign 2 today, and I was like, you know what? They would hate me being thrown in this much. So I just did 1 today, and then part B, I think, comes with 2 questions. The part B you'll do tomorrow. Today is just 1 question. And then we'll talk about all of them in depth on a Zoom on Friday.
Can you talk about how to do D?
Yes. So I had opened this, it might take me a second because I opened this question up about around the time that Jared sent me the text message. So I haven't fully read all of the question in more detail. So we have this tub that's a rectangular shape. And it wants to know the change of depth in the tub at time t = 6. So does anyone still need this piece of fun stuff? Okay, so I'm going to clear it. And so first of all, I'm going to have this rectangular box. And it is filling up with water. And so it wants to know the rate of change. And so this is one of those that we're going to go in and set up. My volume of this one would be the length times the width times the height. Because it wants to know the rate of change in the tub at t = 6. Okay, so with these parts, are the length and the width of this tub going to be changing at all as it's filling up with water since it's a rectangle? No. And so because of it, these two get to be constants. So what were the volume and the width of this not volume, what were the length and width of this rectangle?
4 feet long and 0.5 feet wide.
I'm going to turn that into a 1/2 because my insanity. Okay. And they told us that W is the volume of the water, isn't it? Let's see. The volume is given by W. So I'm going to change V into W for the sake of this problem. Because part A, B, C, and D, they tend to relate in some format, even if it's not in every aspect. Okay, so this one's a related rates problem. So if I want to know about how the height is changing, that means I want to know dH dt, because it's all in respect to time. And so I would take the derivative, which in this case is dW dt, and before I go take the derivative of the other side, I'm going to simplify this to 2h. And so what's the derivative of 2h?
2.
2. And because it's a related rates, it's 2 dH dt. Okay, so after you've taken the derivative, that's when you go in and you try and find out what information do I need to find. And right now I care about the time at what t = 6. I care about the height change at t = 6. Yeah. So, well, dH dt, that's just going to be 8. That's what I'm looking for. I'm finding this piece of information. That's not a pretty circle. I need to do better here. And so with that, dW dt is going to be the derivative at 6. And from part A, we had already talked about what dW dt is just equal to W prime of t. Since it's at 6, which version